Next problem. It says a transversal intersects two lines. Which condition would always make the two lines parallel? Got two lines cut by a transversal. Which of these conditions always make the lines parallel? If vertical angles are congruent, if I say these two angles are congruent, does that mean those two lines are parallel? Aren't those always congruent, regardless? Yeah, that doesn't help us anymore. If alternate interior angles are congruent, if those two angles, those are alternate interior angles, if those two angles are congruent, would that make these lines parallel? Yes. Let's check the other ones. If corresponding angles are supplementary, corresponding angles have to be worked out. Congruent. So that doesn't work out. If same side interior angles are complementary, same side interior angles, which would be this angle and this angle, same side interior angles have to be supplementary. So yeah, that was opposite. Next problem. As shown in the diagram below, lines M and M are cut by a transversal P. If the measure of angle 1 is 4x plus 14, the measure of angle 2 is 8x plus 10. Lines M and N are parallel when x is equal to what? Okay, let's try to find the relationship. There is no special name for angle 1 and 2. I'll rotate that. But there is a special name for angle 1 and this angle. What's the relationship between angle 1 and that angle right there? They are what type of angles? Alternate interior. What's true, Riley, about alternate interior angles? They're the same. So could I put an angle 1 right there as well? Does that make sense to everybody? If this is angle 1, that's going to be the same size as angle 1. So now my question is, what's the relationship between angle 1 and 2? They form a linear pair. They're supplementary. Since they're supplementary, they add up to 180 degrees. So take this, Jagger. Take the measure of angle 1. Take the measure of angle 2 and write me an equation, please. Perfect. They're supplementary, they add up to 180. We solve it, we put our x's together, I have a total of 12 x's. And I believe these two add up to 24, move it to the other side by subtracting, I get 156. Divide by 12, we get x is 13. We're done. I mean, our parallel when x equals 13. That 13 is the solution, but let's actually plug it in and make sure that we're right. 4 times 13 is 52. 52 plus 14 is 66. So both of those are 66 degrees. 8 times 13 is 104. 104 plus 10, I think that's what's going to be. Let's try that again. 4 times 13 is 52. 52 plus 14, no, that's fine, 66. 66 is 63. 8 times 13 is 104. 104 plus 10 is 114. Yeah, we're good there. You can check 66 and 114, they do add it to 114. Next, in the diagram below, you have, and notice the symbol there. L is parallel, those two lines that always mean parallel. L is parallel to M. QR is perpendicular, that's another symbol you need to know. QR is perpendicular to ST at point R. So we have a right angle and we have parallel lines. We got a lot going on here. Measure of angle 1 is 63 degrees. Find the measure of angle 2. Matt, tell me how we're going to go about doing this. Not only is the measure of angle 1 63 degrees up there, Matt, can you tell me another angle that's going to equal 63 degrees? Yeah, well, can we call it angle T? You're right. I know which angle you're talking about. We can't call it angle T because that can be either one of those angles, but RTQ is good. Is also 63 degrees. Everybody good with that? Since RTQ, they're alternate interior angles, makes them same. Does everybody see the Z? Anytime you got a Z, you've got alternate interior angles. And there's your Z right there. Now you have a triangle. Not only is it a triangle, it is a right triangle. So these two angles would have to add up to what? So this would be a 27 degree angle. Any questions? Go on. Chapter 4. Says in the diagram, SV, line SV, or it should be, that's a line. Line SV is perpendicular to RT. I've got a right angle there. They didn't even have to tell us. They tell us in the diagram. VR is congruent to VT. VR is congruent to VT. Tell me something that's true about line VS. I noticed that there's two qualities that line VS possesses. That and that. What type of line is VS? It is perpendicular and it also does what to it? Cuts it in half so it bisects. Good job. So does everybody understand that VS is a perpendicular bisector of this segment RT? Let me remind you of a theorem that states if a point is on the perpendicular bisector. Does everybody understand point S right here is on the perpendicular bisector? If a point lies on the perpendicular bisector, then it is, what's that word? Equidistant to the endpoints. So what kind of triangle is this? A isosceles. This and this is going to be the same. If this is 17, then this is 17. I think that's what it actually defines. No, that's BT. Well, we didn't even have to go that far, did we? We overcomplicated things. But I did want to remind you of that because we got my two previous problems. If this is 8, and that's kind of simple. We didn't have to know anything. If this is 8, then that's 8. Good enough. But all that other stuff is fixing to apply to these other problems. If a point lies on a perpendicular bisector, then it is equidistant to this side. Actually, same problem. You got perpendicular bisector. We went through all that stuff already. Now we're asked to find the length of SR. We did that on that last problem. If a point lies on a perpendicular bisector, it's going to be equidistant from the endpoints. These are the endpoints. If a point lies on a perpendicular bisector, it's the same distance from here to here, so that would also be 17. So SR on that problem is 17. Look at this one. It says in the diagram, since we've gone over all that, since we knew that VS is a perpendicular bisector, what could you conclude about point U? It would also lie on the perpendicular. I like this problem. Point U, if I kept drawing this line, it's going to go through point U. Because the other part of that theorem states if a point is equidistant, if this distance is the same as this distance, then it's going to lie on that perpendicular bisector. So if you continue drawing that line, it would go through point U right there. Because if a point is equidistant from the endpoints of the line segment, then it lies on the perpendicular bisector. And again, that is definitely the perpendicular bisector. On this one, it says AC is perpendicular bisector to BD. Find the length of AB. Again, perpendicular bisector means it's perpendicular and it bisects it. Trace, what would CD? 3 as well. But we're asked to find AD. 2 words. How do we find AD? Pythagorean theorem. Now we can go back, now that we're talking about Pythagorean theorem, we can go back and revisit this type of problems and we can throw a different set of problems at you. If I ask you to find, because you have a right triangle here, if I ask you to find the distance, how far is it from A to B, you can use Pythagorean theorem. A squared plus B squared will equal C squared. In this case, don't use Pythagorean theorem, use Pythagorean triple. 3, 4, 5. Be a bunch easier. Right? Says AC again is perpendicular bisector to BD. Is AB congruent to AD? What do y'all think? Yeah. Why? The same thing I've been saying for the past 5 minutes, right? If a point A is on the perpendicular bisector. If a point lies on a perpendicular bisector, then it is equidistant to the endpoints of that line segment. Here's your line segment. here's your perpendicular bisector. It tells you it's perpendicular bisector. If a point lies on that perpendicular bisector, then it is equidistant to the inference. Any questions? Let's go through and make sure everybody remembers the different types of triangles. The first one, Dillon-Cooper, isosceles. How many equal sides does an isosceles triangle need? Not isosceles. Okay, two. Isosceles. Isosceles. Got two eyes, right? Got two equal sides. So isosceles, which one over there is isosceles? E, that's right. Triangle E. Hunter, equilateral. I mean, what is equilateral? What specifies equilateral? All of the sides and all that. Good. Well, an equilateral, definitely all the angles will be as well, but equilateral, which one's equilateral? And like you said, those would also be equal angular. All three angles would equal 60 degrees. Scalene, Carly, how many equal sides? None. Which one is scalene? C. Actually, is she right? C and F would both be scalene. We know from experience after these type problems, if you've got three different angles, you're also going to have three different sides. So I'll give you that C and F are both going to be scalene. Which one's acute, Alex? C. C and which one? D would also be, yeah, because it's 60, 60, and 60. Yeah, I think E would be acute as well, wouldn't it? What about F? What do you think? Briley, right triangle? A and only A. Now we could test it. How do we test to see if F is a right triangle? I mean, it doesn't look like it, but again, in geometry, don't go by looks. Okay, always go by Pythagorean theorem. A squared, B squared, C squared. On this one, if you do A squared and B squared, you get 36 and 25. If you do C squared, you get 64. 36 and 25 is 61. 64, it's not a right triangle. So we're good with that. So just A, and then obtuse, Riley, which ones are obtuse? L. And from what we just said, C is bigger. So therefore, that would be obtuse, and any other B would be as well. Good job. What is the most accurate name for the triangle below? And when I say most accurate name, I don't want just one name. I want two names. Jagger. This makes it a what kind of triangle? Right triangle. This makes it a, so this would be a right isosceles triangle. Right isosceles triangle. Next one. In triangle ABC, the measure of angle A is x, the measure of angle B is 2x plus 2, and the measure of angle C is 3x plus 4. What is the value of x? Math. What's the relationship between the three angles? In a triangle, it'll always add up to 180. In any triangle, the triangle angle sum theorem, in any triangle, the three angles of the triangle will always add up to 180. So take that information, Colton, and write me an equation, please. Plus x, yeah. Equals 180%. Let's solve it. How many total x's do I have there, Trace? 6. Good. So 6x equals, let's take everything that's not an x and move it to the other side. Looks like 2 and 4, looks like I have 6. To move 6 to the other side, do minus 6, that'd be a 174. Let me tell you how I divide this without using a calculator. Can everybody do 6 times 30 in your head? 6 times 30 is too big, right? How much too big? Didn't we just subtract 6 from that? So 6 times 29 would be 174. So therefore, the value of x is 29. We never just leave it. We always go back and plug it in. So if x is 29, that makes that angle 29 degrees. 2 times 29 would be 58, and 2 would be 60 degrees. And 3 times 29 is 87, and 4 is 91 degrees. I could do several things with this problem. I could not only say find the measure of x, I could say once you find the measure of x, tell me what kind of triangle it is. This would be an obtuse triangle because you have a 91-degree angle. Not only would it be obtuse, it would be scalene. Because since all the angles are different, that means all the sides are different. So you've got an obtuse scalene. I could ask you, okay, there's the angles. Put the sides in order. The angles, there's no problem. I put the angles in order, but let's put our sides in order. And this is not drawn to scale. Here's angle A, here's angle B, here's angle C. Angle A is 29 degrees. Angle B is 60 degrees. And angle C is 91 degrees. Definitely not drawn to scale. Because that looks acute, but I just drew it. Or it looks acute, but it's supposed to be obtuse. So Dylan Cooper, look at these three angles and tell me which side would be the smallest. A. Careful. Angle A is the smallest, but which side would be the smallest? The one across from it. So what do we call this side? I'm not sure. Okay, use your influence. That would be side BC. What would be our middle side there? AC. Because it's across from the 60 degrees. So side AC would be the middle side, leaving what for our largest side? AB. So I could also tell you put the side, find X, find your three angles, and then put the sides in order. So there's a lot of different things we can do with this type problem. Very similar type problem. Instead of telling you what the actual angles are equal to, give you a ratio, 2 to 3 to 5. First off, Carly, is that the angles measures? It says the angles are in ratio of that. Is that the actual angle measures? No. 2, 3, and 5 degrees, that would add up to 10 degrees. That's way too small. Carly, how would you write the actual angle measures? 2, 3, and 5x. And Carly, what does those three angles have to add up to? Good. So that's how you can set up that problem. The three angles of a triangle always add up to 180. I've already told you this is 10x. Alex, what is x going to be? 18. So x is 18. We can go back to here now and find out what the three angles are actually equal to. 2 times x would be 36 degrees, 54 degrees, and 90 degrees. That would be a right scalene triangle. We could go through and we could put the different sides in order, just like we did on the last week. We've got the different angles in order there. Anything else we can do with that? Not really. Next one. It says, in the diagram of angle JEA below, the measure of angle JEA is 90 degrees. We've got that marked already. JEA is right here, 90 degrees. The measure of EAJ is 48 degrees. That's marked as well. Line segment MS connects point M and S on the triangle such that EMS is 59 degrees. Let's find them all. It says find the measure of angle JSM. That means bottom. Let's just go ahead and find them all. Riley, let's start here. Can you tell me how big this angle is? 121 degrees. Those two angles form a linear pair. Anytime you have a linear pair, there's something there to add up to 180. Anybody, angle J. And notice I can call that angle J. That's the only angle at that point. Angle J. How in the world are you going to figure out what angle J is, or tell me what's angle J? Don't lose the big picture. A lot of people see this small triangle and they see this quadrilateral here, but they lose track of the big picture. Does everybody see that there's a large triangle over here? The corners of that large triangle are 90 degrees, 48 degrees, and the third corner would be 42 degrees. Now we can deal with this third angle, because now you have a small triangle. The small triangle has corners of 42 degrees, 121 degrees, and while we're at it, let's go ahead and find this one. Linear pair, 17 degrees and 163 degrees. There was another way of working that, which we'll actually get to later. Does everybody see the quadrilateral at the bottom? 4 sides, 4 angles. Does anybody know what the 4 angles of the quadrilateral? 360, yeah. You could have worked it that way. If you knew this was 90, you knew that this was 59 and 48, you could have added those 3, took it away from 360. That's the coming. That's a couple more chapters down the road. Took it away from 360, you would have got the 163, and then you could have used linear pair there and found that 17 degrees, which I think, yeah, that's what you're looking for. 17. In right triangle DEF, the measure of angle D is 90 degrees. Let's draw it. Measure of angle D is 90 degrees. The measure of angle F is 12 degrees. And, ooh, no it's not. Let's try that again. Let's read the whole thing before we start drawing stuff out. That'd be as far as E, F. The measure of angle F is 12 degrees less than twice the measure of angle D. The measure of angle F is 12 degrees less than twice the measure of angle E. We don't know what the measure of angle is, right? We call it X. But L, let's relate those two angles. Let's use that measure of angle E to kind of write a sentence explaining how big F is. 12 degrees less than twice the size of E. Riley, what if I just said the measure of angle F is twice the measure of angle E? What's that twice mean? Yeah, 2 times bigger. So if it was twice as big, it would just be X and 2X. But it's 12 degrees less than twice as big. So anybody, how do I do 12 degrees less? Good. So there's my 2 angles. Measure of angle E is X. Measure of angle L is 2X minus 12. What's the relationship, Jagger, between measure of angle E, between this angle and this angle? What are they going to add up to? Good. Say again? 90 degrees. Since you've got a 90-degree angle here, the 2 acute angles, the 3 add up to 180, so these 2 would have to add up to 90. So my equation here, the 2 angles, when I add them together, will equal 90. X and 2x is 3x. We move the 12 to the other side, gives me 102. Somebody divide that by 3 for me, please. And you get 34. So x is 34 degrees, which is the measure of angle E. And you can plug that in if you want to, just to test. 2 times 34 is 68. 68 minus 12 is 56. And you can check that 56 and 34 do also add up to 90 degrees. In the diagram of triangle ABC below, AB is congruent to AC. Matt, since AB and AC are the same, what type of triangle is that? Isosceles. And since it's isosceles, not only is AB and AC going to be the same, but Colton, what else is going to be the same? If you have 2 equal sides, good. If B is 40 degrees, C is 40 degrees. Angles give sides their length. And it says, what's the measure of angle A? Before we find the measure of angle A, can anybody remind me of what type of angle A is? In an isosceles triangle, you have 2 base angles, and you have a vertex angle. A is the vertex angle. It's not equal to the other 2. But trace, one more time, what's the 3 angles add up to? 80. So these 2 add up to 80. This one must be. Any questions? It says in triangle ABC, and again, let's draw that. Triangle ABC. It says that AB and BC are the same. A, B. Now I'll draw that. There we go. AB and BC are the same. And altitude is drawn from B to AC. We hadn't talked a lot about altitude, but can anybody tell me another name for altitude? Height. Height must be perpendicular. So an altitude is drawn from B to AC and intersects AC at point B. We want to know what all is true, or what all these conclusions could we draw from this picture. First off, is the measure of angle ABD congruent to CBD? Well, let's do this easy. When I take an isosceles triangle and I draw an altitude, is that a perpendicular bisector? Yeah. I told you before, an altitude or a perpendicular bisector that's drawn cuts an isosceles triangle into two congruent. They're mirror images of each other. Because think about it. These sides are the same. These angles are the same because it's an isosceles triangle. What else is the same? We've got, let's see, if a point lies on, if a point is equidistant, remember that? If a point is equidistant from endpoints, that means it lies on the perpendicular bisector, so we know that those are the same. Pretty much, you can see there, you're going to have two completely congruent triangles. They're mirror images of each other. So question, is ABD, which is right here, going to be congruent to CBD? Anybody? Complete mirror images of each other? Yes. Is BDA, find BDA, congruent to BDC? Yeah, because they're perpendicular. Is AD and BD the same? AD and BD, oh no, that's the one that's not. Is AD and DC? Yeah, because it lies on a perpendicular bisector. Move along. In the diagram below, triangle LMO is isosceles with LO congruent to MO. Since LO and MO are the same, you see, Dylan, that's an isosceles triangle flipped upside down. Flip it back over and tell me, will angle 1 or angle 2 be the same thing as this 55 degrees? Will this angle 1 or this angle 2 be 55 degrees? No. One of them will be. Which one? If you have an isosceles triangle, let me flip it back over again. Anytime you have an isosceles triangle, the angles across from those equal sides will also be equal because that's what gives the side of this thing. So LMO or LOM? Angle 1 down here, do what? LMO will also be 55 degrees. Isosceles triangle, it's upside down. NOM is 28, to do that. Find the measure of angle N. Here's what you're looking at. Is this angle over here. So 55, 55, those are your base angles. What's this angle? 7. The three angles add up to 180 degrees. Now, how in the world do we find this angle? Any ideas? 55 would be a linear pair. That's one method. 55 would be a linear pair to this one. So that would make that 125. So really we didn't even need the 70, did we? There's another way I'm fixing to show you that you would have needed the 70. So now you can do 125, 28, and the other way you could have worked it, and that's where I was fixing to go. The other way you could have worked it, don't forget about your big triangle. The big triangle has corners of 55, 98, and your unknown. So you could have done 55 plus 98, subtract that from 180. That would have also given you 26 degrees. In the diagram below of triangle ABC, AB and AC are the same. AB and AC. You have angles of 3x, x plus 20, and I have no idea. Anybody tell me how big this one is? Also x plus 20. Those two base angles will always be the same. Hunter, use the facts here. Use these three angles in right-hand equation. 2x plus 4 plus 3x equals. I like the way it is. He did 3x plus 2x plus 40 equals 180. We went ahead and added x plus 20 and x plus 20. That's fine. Which gives us a total of 5x equals, we can move the 40 over by subtracting. So x must be 28. To check ourselves, we always go back and plug it back in. 28 is 48. 28 is 48. And 3 times 28 is 84. And again, I could ask you those same questions. What kind of triangle is it? It would be isosceles, isosceles of 2, so 2 is isosceles. I could ask you which side lengths are the longest, which side lengths are the shortest. Obviously here, your bottom side is going to be longer because you have a bigger angle. Not because it looks longer, but because you have a bigger angle across them. In the diagram of triangle KLM below, the measure of angle L is 70, M is 50, and you've got that labeled. The measure of K is extended through M. What is the measure of LKN? We're on a different topic now. LKN, we're looking for that angle. Interior versus exterior angles. LKN that I just marked. Carly, is that an interior or an exterior angle? Exterior. Do you remember what's the relationship between exterior angles and the interior angles? This LKN will equal, how do I find it? The sum of the two remote interior angles. So Carly, can you tell me how big this will be? 100 and, these are your two remote interior angles. That one and that one. If you add them together, you get 120. Any exterior angle is equal to the sum of the two remote interior angles. Again, the way that I told you to remember about remote interior angles, if your couch was sitting right here, and your television was in either of these corners, you would need a remote control down there. Right? If your TV was sitting here next to your couch, you would not need a remote. So remote interior angles are the angles across from. So any exterior angle will equal the sum of the two remote interior angles. So LKN is 120 degrees. You could have went about that the long way. The long way would have been 70 and 50 added together to give you 120. You could subtract that from 180 to get this angle, and then subtract that from 180 again to give you that angle. You can work it either way. Another one? It says in the diagram below, you have ABC and AC extending through. So we've got an exterior angle, and you've got, here would be your two remote interior angles. It says BCD, which is this angle here, would be 6x plus 2. And now I don't know if y'all worked anything like this. I won't write it down. BAC, which is this angle, is equal to 3x plus 15. And you have ABC, which is this angle, is equal to 2x minus 1. Reminder, the theorem states an exterior angle will always equal to the sum of the two remote interior angles. So, Alex, write for me an equation.
2x minus 1
Perfect. The exterior angle is equal to the sum of the two remote interior angles. Let's take all of our x's, and in this case, let's move to the right, because it looks like I have 5 over here. When I move it over there, I subtract those 5, and I'm left with 1x. Let's move all of our numbers to the left. I have 15 minus 1 over here already. That's 14. When I move plus 2 over, I do minus 2, which gives me 12. So x is 12. We plug all those in. That gives me 36 and 15 is 51 degrees. 24 minus 1 is 23 degrees. And that makes us 72 and 2 is 74 degrees. And you can say, is 51 and 23 add up to 74? It does. And I can go a step further. I can say, find all of that and tell me what that angle is. So we have several different ways that we could learn this question. In the diagram below, still triangle ABC, D is a point on AB. AC is 7, you're given that. AD is 6, and BC is 18. We're asked to find out what are some possible, which for some reason I cut off the question. What are some possible values of DB? What has to be true about the three sides? The two shorter sides have to add up to be larger than the bigger side. So here, which one's the shorter side, which one's the longer side? I really can't tell. I think this bottom one's supposed to be the longer side. Well, let's treat it. Let's look at both scenarios here. Let's let this be my x. X is the distance from here to here. And let's think of some values here. Could x be, I don't know. You tell me. What could x be? What could x not be? When you add 7 and 18, if this is my longest side, when you add 7 and 18 together, what do you get? So, if that was my longest side, what can x not be? If x was 19, you see what would happen? And this is definitely not drawing the scale. So I don't know the scale very well. If x were 19, that would give you 25 here at the side of the collapsing. Okay, so what if x was bigger than 19? It would be even worse. If you extend this out even farther, it would definitely collapse. So x must be smaller than 19. Now let's look at the other scenario. What if this is the longest side? What if 18 is our longest side? Okay, we got 7 here that's looking to fold in. What can this not be? 5. This cannot be 5 because look, if you take your 7 here, and if this were 11, it would again collapse in on each other. 7 and 11, that gives me 18, so x can't be 5. But does it need to be bigger than 5 or does it need to be smaller than 5? If it's smaller than 5, let's look at 4. If x were 4, that would make this side length 10. That'd make this side length 7. Would that fold in? Yes. So it needs to be bigger than 5, correct? So x has to be less than 19, and it also needs to be larger than 5. Let's write it like this. X needs to be larger than 5. I just wrote it backwards. And x needs to be smaller than 19. So your missing length right there needs to be between 5 and 19. That's pretty tough problem. Which set of numbers represents the lengths of the sides of the triangle? The two smaller sides have to add up to be bigger than the third side. Look at your first one. 5, 13, and 18. You put them in order. What's 5 plus 13? 18. Can't equal. Okay. The two shorter sides have to be bigger than the third side. Riley. 6, 17, and 22. Add 6 and 17. What do you get? 17. That's the two smaller sides. You're adding together. 23. Is that okay? Yes. The next one, 16, 7, and 24. 7, 16, and 24. Somebody add 7 and 16 for me. 23. Is that okay? No. No. 8 and 15 are the smaller sides. Add them, you get 23. Not okay. The two shorter sides have to add up to be bigger because, once again, if we drew it, if this were 22 and this was 6 and 17, if you start folding that in to form a triangle, if these were smaller than 22, they're going to fold in completely. 6 and 17 will hit before you get 22. Thanks, Rob. In triangle ABC, measure A is 95, B is 50, and C is 35. And you can add those together, and you're going to get 180. They're legitimate here. Which expression correctly relates the length of the sides? And we do know that side lengths and angle lengths are connected. If you need to draw it, you can do it. A, B, and C. A is 95 degrees, not drawn the scale. B is 50 degrees. C is 35 degrees. Jagger, where's the smallest side going to be located? Across from where? It will be BA. Your smallest side is going to be located across from the smallest angle. So like you said, AB or BA will be the smallest side. What's going to be the next smallest side, Matt? AC, and that leaves BC for the largest side. Smallest sides across from the smallest angle, the biggest sides across from the biggest angle. So putting those in order. AB is the smallest, so AB is less than AC, and AC is less than BC, so AB less than AC is less than BC. In a scaling triangle ABC, the measure of B is 45, C is 55, but they don't give you the third angle. Dalton, what's the third angle? Good. 80. So you have B is 45, C is 55, and like we said, A is 80 degrees. Have that at 180. What is the order of the sides from longest to shortest? Trace, which one's the longest side? BC, so we can rule out that one and that one. BC is the longest. Dylan, what's the middle side? BA. Good. So we have BC is the longest, BA is the middle side, and that would make AC the short side. A reminder about circumcenters, incenters, and centroids. And let's before we work the problem, let's go through the whole gamut of them. Circumcenters. The circumcenter is where the three what's cross? Perpendicular bisectors. The circumcenter is used to draw a circle around a triangle. Perfect. The incenter is where the three angle bisectors cross, and the incenter is used to draw a circle inside the triangle. A centroid is where the three medians cross, and what would you use the centroid for? To find the center of gravity or the center of balance. Perfect. In the diagram below, AE is congruent to BE, so that makes E the midpoint. Everybody understand that? AF and CF are the same, which makes L the midpoint. CD and BD are the same, which makes D the midpoint. So it looks like you're drawing a line from the angle to the midpoints. Point P must be a central. You just drew three medians. A median goes from an angle to a midpoint, so that would make it a centroid. We didn't do it in class. Orthocenter, though, is where the three altitudes cross. Not as useful, so that's where you can skip over it. The vertices of the triangle in the diagram below are 7, 9, 3, 3, and 11, 3. What are the coordinates of the centroid? One more time. Hunter, how do we find the centroid? We draw the three what? Medians. So we need the three midpoints. Because a median goes from an angle to a midpoint. To find a midpoint, let's do 7, 9, and 11, 3. Find the midpoint, Hunter. What do you do with your x's and what do you do with your y's? Perfect. Add your x's, anybody divide by 2, you get 9. Add your y's, divide by 2, you get 6. It's right there. That's pretty. Could you tell by looking at that where it's going to be? Probably. And the other two, if you can tell, that's fine, because you got a graph. That's going to be the middle, right? But if you can't tell, add your x's, 3 and 7, divide by 2, you get 5, right in the middle. 3 and 9 is 12, divide by 2, you get 6, right in the middle. 3, 3, and 11, 3, add your x's, you get 14, divide by 2, you get 7. Add your 3 and 3, you get 6, divide by 3, you get, or divide by 2, you get 3. So there's your three midpoints. You draw the lines, and they all three cross, right? That would be your centroid. Centroid is located at the point 6, 5, I believe is that centroid. Any questions? In In the diagram below, triangle ABC, CD is a bisector of BCA. CD is a bisector. Let's see, this CD is a bisector of the angle, which means this and this is the same. It also says that AE is a bisector, angle bisector, which means that and that's the same. And it's going to say, without even reading it, that that's also going to be a bisector. So you have three angle bisectors drawn. So which of these statements must be true? First off, this is not one of them on the list. What is G? It's a point of concurrency where the three angle bisectors cross, which makes it a incenter, or an incenter. So if G is the incenter, that means we could use G to draw a circle inside the triangle. Right? Which statement must be true? Is DG and EG the same length? Yeah. I don't know. We'll put a question mark next to that and come back to it. Is AG and BG the same length? Maybe. AEB is congruent to AEC. AEB is congruent to AEC. Here's what we got to be careful of here, because I think their logic is off here. I think the problem is off with it. DBG and EBG. DBG. Now that was true. Okay, yeah, never mind. I thought only one was false, but only one's true. That's the only one that could be, or that is true. DBG, which they tell us that this angle and this angle is the same. Now let's talk about, because a lot of people are saying, but this is the same because I can draw a circle in here. Here's something they left off. If you wanted to draw a circle inside here, the distance from here to the outside, and do you remember what has to be true about distance? It must be perpendicular. Do we know that this is perpendicular here? No. Does it even look perpendicular right here? It doesn't, does it? There's only one type of triangle to where an angle bisector would be perpendicular here, and that would be an isosceles triangle. If these two sides were the same, yeah, then it would be perpendicular. Or in an equilateral, all three of them would be perpendicular. So when I go to draw a circle inside here, okay, the distance from the center to the outside, if it had a perpendicular distance there, yes, those two distances would be the same, because that distance would actually be our radius, right? All three of those distances there would be the same, but not necessarily the distances that they gave us. Triangle ABC has vertices at 3, 3. That's A. At 7, 9, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 9. That is B. And at 11, 3. 7, 8, 9, 10, 11. That's C. You're asked to determine the intersection of medians and state the coordinates. What are we actually looking for in this problem? The intersection of medians would be your centroid again. And we've already done one of these problems, so I'm not going to go through the entire thing. Let's just talk about how you would work it. Once again, same as the last problem, you find the middles. There they are. Without even working it out, there's the three middles. You would connect the angle with the middles, the point of intersection, which is going to be, I think, right there, would be your centroid. Is that the same problem we worked with before? It looks nearly identical. Look at triangle ABC. O is the centroid. Again, a centroid is a center of balance, but there's some other stuff that's also true about it. Which statement is always correct about triangle ABC? Segments BO and OE. When you're dealing with a centroid, see how much you remember about this. Is BO and OE the same length? No. Do you remember what the relationship was? 2-to-1 ratio. BO would be double the length of OE. So are BO and OE congruent? No. BO is double the length. Is segment DF and AE DF is the distance from here to here. AE would be the distance from there to there. DF and AE, would those be congruent? I don't know, let's come back to that. Segment CD and BE are congruent. CD and BE are congruent. I think this might be touching on something we haven't gotten to. CD would be here. BE would be here. Would those be congruent? I'm not sure. Segment AE and EC. Which one is true? That one has to be true there, doesn't it? Segment AE and EC have to be the same. Because a centroid connects an angle to the midpoint of opposite side. So therefore, or a median does. A median connects an angle to the midpoint of opposite side, so that must be the midpoint, so AE and ABC are the same. But you do, that was a good review of this as well, 2 to 1 ratio.